All right, so let's take a look at number 3. This is to find a particular solution to the given equation. Okay, so first I noticed the left-hand side is the same. The only thing that's different from problem 1 and 2 is the right-hand side. Okay. All right, so let's go ahead and find the particular solution since we already know the complementary solution. So yp of t, this is going to be, I'm going to take on a form, well, this is our g of x. So I'm going to take a general form and say a times sine of 2t. All right, so this first part is the guessing game. So this is what I'm guessing. Fortunately for us, if you go back to problem 1, our guess of a times e to the power of 5t, this worked out because we got a nice clean number, the constant number, which was -3/7. So we'll see if that's the case for this problem too. All right, so if this is our guessed value of the y, then let's go ahead and calculate the y prime of t. This is going to be 2a cosine of 2t. And y double prime of our particular solution is, that's going to be -4a sine of 2t. All right, so I'm just going to go ahead and plug these values into our original equation. So that's going to give us -4a sine of 2t minus 4 times 2 is 8a cosine of 2t minus 12 times y, the particular solution, is just a times sine of 2t. And we know that this is going to equal to sine of 2t. All right, so just getting the like terms together. So we have, let's see, -16a sine of 2t minus 8a cosine of 2t. That should equal to our sine of 2 times t. Okay, so from here, I know that probably this value, so -16a, should equal to 1, because that's the constant here in front of us, in front of the right-hand side. And also this part, -8a, should equal to 0, because I don't see any cosine terms. So this would result in a equal to 0, and this is going to result us to have -1/16. So this is the case where our original guess of our particular solution having this form fails. Okay, so we're going to go ahead and have to take a different guess. And this, once you fail, go back to the form, and this should give you a lot of hint. And usually your second attempt is the one that is going to work out. So it seems like I'm going to have some kind of sine and cosine involved, not just sine itself. Okay. All right, so let's go ahead and continue on. Now this time, my guess for the particular solution of t, this is going to take on the form of a times cosine of 2t plus b times sine of 2t. Again, I've added the cosine term to it in addition to the sine, and each of the terms will have the coefficients multiplied, a and b. All right, so first order differential equation of this would be -2a sine of 2t plus 2b cosine of 2t, and y double prime would be -4a cosine of 2t minus 4b sine of 2t. All right, so plugging things into our original equation, it's going to be a long one, but it's going to be negative 4a cosine of 2t minus 4b sine of 2t minus 4 is going to be multiplied to the y prime, so that's going to give us plus 8a sine of 2t minus 8b cosine of 2t. And lastly, multiply negative 12 to our original y. So that's going to be negative 12a cosine of 2t minus 12, it's going to be minus 12b sine of 2t. And that's going to equal to sine of 2t. All right, let's get some of the like terms together. So you have the cosines, 1, 2, and 3 of these. Okay, so that's going to give us negative 16a minus 8b cosine 2t. And the rest of the sine terms, that's going to give us plus 8a minus 16b sine of 2t, and that's going to be sine of 2 times t. Alright, so here we get something like negative 16a minus 8b. This should equal to 0 because I don't see any cosine terms on my right-hand side. Okay, and the second equation I have is 8a minus 16b. This should equal to 1 because the coefficient I have on the right-hand side in front of the multiplied to the sign is just 1. Alright, so I'm going to keep this because I like the fact that it nicely ends with 1. And from the first equation, I'm going to divide both sides by 2. So negative 16 divided by 2 is negative 8a, and 8 divided by 2 is 4b, and 0 divided by 2 is just 0. And I'm going to add these two equations. So that's going to give me negative 20b equals to 1. So finally, I can get my b value, which is negative 1 over 20. If I plug in this negative 1 over 20 to one of these equations, I will get my a value as 1 over 40. Alright, so there we go. Our final answer for this particular solution is going to be 1 over 40 cosine of 2t minus 1 over 20 sine of 2t. And this is our answer to question 3. Alright, and if I were to ask the general solution instead of the particular solution, then it would be just the sum of the particular solution and the complement solution, which was if you go back to the very first, it would be this part should be added to our equation with the particular solution that we got. Alright, so let's move on to problem 4. So this time we're still having the same, consistently having the same left-hand side, and we just have a different right-hand side. Okay, so what we've seen, if we have the sine or cosine, I think it's generally a better idea to add a sine of 3t plus b cosine of 3t. So here's a similar case. If we were to find the particular solution, it's better it's better to start with the highest degree, which is t to the power of 3, and just go down, including all of the terms, even though we don't see the term for t squared in this case. So what I mean is we can guess that the particular solution will have the form of a times 3t cubed plus b times t squared plus c times t plus d. This has to be true because it's in the most complete form. So let's go ahead and check. Let's take the derivative of this, which we'll get to. 3a t squared plus 2bt plus c. And second derivative would be 6at plus 2b. All right, and let's go ahead and apply all of these into our original equation. So we have 6at plus 2b minus, we have to multiply 4 to all of these. Then it's going to be negative 4 times 3 is 12at squared. Negative 4 times 2 is negative 8bt, negative 4c. And lastly, we have to multiply negative 12 to all the terms. So we have negative 12a t cubed minus 12b t squared minus 12ct minus 12d. And we know that this has to equal 2t cubed minus t plus 3. All right, so let's take on all of our like terms. So we have this negative 12a t cubed, and I think that's the only term with t cubed. Now let's take on the t squared. We have this one and also that one. So we have two of those. I'm going to write them vertically. So we're adding negative 12b minus 12a t squared. Okay. And let's now add the t's. So those three things are the ones that we see. So we add 6a minus 8b minus 12c t. Okay, and lastly, just the terms without the c's. We have those three. So we have plus 2b minus 4c minus 12d. All right, so we have this equals to, our right-hand side is 2t cubed and 2t cubed, and we have 0 here. We have no t squared term, minus t plus 3. Okay, so from here, from the first line, we have negative 12a equals to 2, so that'll get us the a value of negative 1 over 6. Okay, we can plug that in to our second part here to find the value of b. So we have negative 12b minus the negative 12 times negative 1 over 6 would be positive 2, and this should equal to 0. So by subtracting 2 both sides and dividing by negative 12, we have b equals to positive 1 over 6. All right, and we can also plug those values in to find the value of c for the third line, which will get us as c equals to negative 1 over 9. And likewise, our d should equal to negative 5 over 27. All right, so plugging those values in accordingly to here, get this, and this is our solution, the particular solution of our given equation.